sorry, but it will be in English, as Gregory said. If you want to interrupt me or ask me any questions, just do it in French, because that way I can train myself. I don't get many opportunities to speak and listen French. So I'm going to talk in English because it's easier for me and it will be better for you. That's my gift to you for tonight. And the idea for tonight was to talk about some uncommon uses for Redis. I had the idea of talking about 2 different things, but given that we have another presentation, I will probably talk about finite state machines in Redis the next time. And tonight will be about how to use Redis as your main database. Okay, so I'm Michel Martens. I'm from Argentina. My username on GitHub, Twitter, everywhere is Sovereign. I'm a member of the Redis organization on GitHub, moderator of the Redis mailing list. It's not a lot of work, it's almost nothing, but moderator of the subreddit, maintainer of the Redis.io website. I'm co-founder of OpenRedis, which is a company that offers Redis hosting. It was created in 2011. At the time, when I discovered Redis, I was working at a company in Los Angeles, and I fell in love immediately with Redis. I wanted to use it for everything, and I tried to convince everyone in the company to use it. So I was the guy that installed Redis and configured and everything. So a couple years later, I launched this service. It's a very tiny company. We're 4 people only, but it works so far. And I also made some other contributions to Redis, like some commands, things like that. I had the idea for the logo. That's my biggest contribution. And this is from something that Salvatore, the author of Redis, said in the first Redis meetup ever. He was talking about how you can, given that it's a server, a data structure server, you can arrange those data structures to accomplish many different things. And he said that Redis has many souls. And I think I want to put that because that's like the spirit for tonight, how to do many different things, like the search engine, for example, or using it as your database. And well, this talk is about how to use it as your main database. I will be talking about mostly this library called Ohm. It's a library originally written in Ruby, but it has been ported to other languages like Lua, Crystal, Objective-C, many others. Ohm is an object hash mapper. It translates objects in your native language, programming language, to hashes in Redis. It is almost as old as Redis itself. So the first version of Ohm came out, I think, 2 weeks after Redis was released. And the inspiration was, when Redis was first released, there was a tutorial for how to create a Twitter clone. And in that tutorial, Salvatore showed how to arrange the keys, how to simulate a structure with the keys, names of the keys, and how to use sets for finding records. So that's what inspired this library. So this is a very simple example just to show you something that may be familiar to the languages you use. So this is how you define a model. with 2 attributes, name and email, with an index on name and a unique index for email. So this sounds familiar, the things you do. There are more complex things that you can do, like having one-to-many relationships and things like collections. But, well, this is just to show how it works. Yeah. You can't. I mean, with Ohm, you can have references to other models, like one-to-many or one-to-one. That reference can be to any object that it doesn't have to be to another instance of Ohm. You can have a reference to an active record, for example. I don't think you can do the opposite. I don't think if you, without active record, you can have a reference to an Ohm object. I don't know. But the opposite is true, and I know people that use it like that. Okay, so with this definition, we can do, let's say we have these attributes. This is a hash in Ruby. We can pass that hash and create a new instance of user. We can ask for the name. We can ask for the email, the ID. And given that we have indices, we can find all the users that have that name. We can combine several different filters. We can find all the records that match certain condition and remove from that set all the records that match some other conditions. And okay, this is a very simple example, and we will be talking about how to represent this data in Redis, how to define the keys to give some meaning to the keys we are using, how to make everything within a transaction, because if we save the object at one moment and we index it at the next moment, something in the middle can go wrong. And finally, we will see how to query this data, how to implement those filters. So we will cover just these 4 things. So the first one, it's maybe trivial, because Redis has two data structures that are perfect for representing the attributes and the indices. So for the attributes, we will use hashes. And for the indices, we will use sets. This is a very simple example of using Redis to set the attributes. For example, the command hset sets a field in a hash. So here I'm calling hash set. User1 is the name of the key, name is the field, and François is the name. And you can already see that we are using some kind of structure in the key. We're using the column user column 1. For Redis, it means nothing, because for Redis it's just a string. But for a human, we already have some idea of what we are trying to say here. We're talking about the user1. We can use hashget to get the value. We can do the same with the email and get the value back. As for sets, we will have a set of all the users. Right now we have only one user, so we can add. We use the command set add to add the number 1 to the set of all users. And with the command set members, we can get back that collection of all the users. So far we have only one. The Keyspace layout is what I was talking about using the colon to separate the structure. If you were here in the previous meetup, there was a very nice explanation of how to do that and why. And I want to talk about this little library, which is like a helper for building those kinds of keys. The idea is to, given that the key space is flat in Redis, it's just strings, the idea is to simulate some kind of structure, both for humans reading the keys and for the application. So the application will make sense of the keys. So an instance of Nest behaves like a string. So here is just like the string user. But let's say I save this value in the variable key, and then I can do things like this. For example, if I pass a set of brackets and a string, it builds the key with the colon. If I pass a number, it again generates the colon and the number. And I can keep adding brackets and it will generate this kind of structure. So that is handy for writing code that has to generate these keys. But these keys are also, they allow you to send commands directly to Redis as if they were object oriented. For example, I have this key and I can call a command on this key directly. So the key is user1 and the type is hash. I can send hash get and ask for the field name, and I get the field back. This is the set of all users, and I can call the set members command and see what members there are. So in itself, it's not very useful, but if you are building another tool, it's very handy to have a shortcut for these kind of things. And this library is part of Ohm. For transactions, there are two ways of doing transactions in Redis. One is by using multi and exec. Those commands allow you to send commands to Redis. Redis will save the list of commands, and then when you run exec, it will execute all the commands at once. The other way is with Lua scripts. Mm-hmm. So the Ohm scripts are two scripts, one for saving objects, one for deleting objects. The fact that Redis allows you to run Lua scripts is thanks to Pierre here, because he is the one who suggested Redis to have the scripting. So thank you. And these two scripts allow you to store the objects in Redis. You just pass a JSON with the fields and attributes, and it takes care of indexing and everything. And all that happens within a transaction, so you don't get any inconsistency. And finally, how to query Redis for data. By using set algebra of sets. So I want to show you another library, but first I want to show you what's the problem with doing set algebra with Redis. So first, short example. Let's say we have these three sets: A with 1, 2, and 3, B 2, 3, 4, and C with 3, 4, 5. We can do this kind of operations like the union of A and B, which is 1, 2, 3, 4, the intersection of B and C, the difference between A and C. So far, so good. Okay. But we can also do more complex things. We can first calculate the union of A and C, and then calculate the difference between that set and B. So what is the answer here? Nobody was paying attention. Okay. Almost. So yeah, union of A and C is 1, 2, 3, 4, 5. B is 2, 3, 4. So we get 1 and 5. And we can do this with Redis. Let's say we create a set A with numbers 1, 2, and 3. A set B with numbers 2, 3, and 4. The result we get, the number 3, is the number of elements that were added to the set. So if we run this command again, we get a 0 because the values are already there. We create another set with 3, 4, and 5, and we can do the set union. We can do the set intersection. We can do the set difference. And when it comes to this more complex operation, we have to do several steps. For example, we have to first calculate the union of A and C, and we have to store it in a temporary key. And then we can do the difference between that set and B. And finally, we probably want to delete that temporary key. So we can do this very easily, but it can get more complex. We can have more complex operation, and doing this procedurally is not very practical. So there's a library called stall that takes care of solving this kind of more complex operations. If we define the problem like this, it's very procedural and complex, but we can use, we can define it as an X expression. So we put the command first, and the operand first, and the operator first, and the operands later. And this new shape allows us to build the operation incrementally. If we replace the operators with the Redis commands, it would be something like this. So Redis doesn't understand this, but we have style, which is a library that will translate this to something that Redis understands. So this is Ruby. It's the way to define this S expression in Ruby. It's an array with an array inside. That's the first operation we want to do. And the result of that, well, we want to do the difference between that result and B. If we assign this to a variable, we can pass the expression to stall. We pass also a Redis client, and we get the result. And stall will take care of building any temporary keys and then deleting any temporary keys. It will take care of doing everything within a transaction and pipelining all the operations. So it's the best performance you can get for that kind of operations. And what is good is that you can also explain and see actually what steps it's going to do. And about building gradually, in Ohm, sometimes you have this expression, but if you want to combine it with other filters, you get a new expression with the previous expression embedded. So there I'm putting the previous expression. And in the end, stall will expand all this and solve it. Okay, so combining these two tools with these three tools, the nest for building the keys, the Ohm scripts for the transactions, and style for the set operations, we get pretty much what is Ohm. And finally, I know it's there's a psychological barrier to using Redis as your main database, because there are some constraints in Redis. For example, all the data has to fit in memory. That's a big constraint. And also there's the risk of losing data. But sometimes if your problem, if what you are trying to solve is not affected by those constraints, what you gain is you get to use the fastest database there is. So here are some tips for how to configure Redis, or what common problems you might find. So this is a very common problem. People that don't configure a max memory limit and they just crash the server. So even if you have monitoring in place and you know what you're doing, this is one of the most common problems among Redis users. Also, you have to configure a max clients limit. This is the second most common problem among Redis users. If you reach the max clients limit, you can do anything. You cannot even log into Redis. So you need to have a max memory limit and max client limit and a lot of alerts. There's a lot of documentation about the persistence modes for Redis. You can get anything from the same guarantees of Postgres and MySQL, and you can have almost no guarantees and a lot of volatility. So if you read that document and you know how to configure it, you will find how to fine-tune it for your use case. For example, one configuration that is common to most databases is to synchronize to the file system every second. In Redis, you can do a lot of operations per second. So if you sync every second, you can lose a lot of operations if you are doing a lot of operations. So you have to make sure you're using the right kind of persistence and that you test your use case. And this is also very common, people that just restart the nodes and expect that everything will work. But Redis is not designed that way. If you are restarting a node, you have to try it before. You have to check that it's supposed to do what you want it to do. Luckily, Redis is very simple to install, so you can try every combination you want. The same goes for Redis Sentinel or Redis Cluster. You can just try your ideas and see what works and what not. And above everything else, you have to avoid running slow commands. Something that's key is that Redis is single-threaded. So if you run a slow command, you block everything else. And a lot of big problems happen because people run slow commands in production. I don't want to name names, but there are big companies that run into these kinds of problems. So it's something to pay a lot of attention. There are many tools for that for diagnostics, so you can check which slow commands you are running, but it's something to keep an eye on. And finally, you can ask me or anyone else in the community. It's a very helpful community. There's the Redis room on IRC, on Freenode. you can ask there, and there are a lot of people willing to help. You can ask me on Twitter, that's my username. You can contact me from my website too. And this is the list of libraries I was talking about. So Ohm, Nest, and Stall. Nest and Stall are part of Ohm. So, but you can use them separately, and you can try them in your own language. They are very, very simple. Nest, for example, is like 15 lines of code. Stall is like 50. So it's very easy to get the concept, and if you need it, you can port it to any other language. And that's it. That's all I have.